Alright, so in this video, we're going to evaluate the following integral. The integral of sine of kx dx. So how do you suppose we start this off? Well, we could do a u substitution by setting u equal to kx. Therefore, du is just the derivative of this thing. And we're going to take the derivative of this thing with respect to x. We know that the derivative of kx with respect to x is k. And then we just have to put a dx there. We can divide the k to the other side, and we would get this. So what we're going to do is we are going to substitute kx for u and dx for 1 over k du. So this is our new integral, now in terms of u. 1 over k is just a constant, so we can pull this to the outside of our integral. And so, as we can see, all we have to do now is evaluate the integral of sine of u du. But if you recall, the integral of sine is one of our basic trigonometrals. If you recall, the integral of sine is negative cosine. And then, of course, we get the plus c. I'm just going to move the negative to the outside. And so we've evaluated our integral, so we're going to resubstitute u back in terms of x. So I'm going to replace u with kx. And so this is our final answer. But this is only our final answer, provided that k is not equal to 0. Otherwise, if k is equal to 0, then you would do 1 divided by 0, which you can't do. So this is true as long as k is not equal to 0. So then what if k equals 0? Well, you'd have the sine of 0x, which is the sine of 0, and sine of 0 is 0, so you'd have the integral of 0 dx. But the integral of 0 dx is a constant, so you just simply get a constant. So this is true if k is equal to 0. Of course, for practical applications, I like that word, practical applications, we care about the cases where k is not equal to 0. But this is to be complete. Because all we said at the beginning of this video was that k is a constant. So yeah, that's pretty much the way it works. So yeah, that's pretty much it for this video.